Hope you guys enjoyed Christmas and New Year's and Hanukkah or whatever you celebrate. Starting off the new year fresh is always a good thing to do. I went home, played a lot of Halo and Call of Duty. That's pretty much all I did. So let's get started this new year with linked list cycle. I actually had this exact problem in my Goldman Sachs interview, my on-site interview, which I was able to perform well on because I knew the trick. I definitely think that this is a good problem to cover. Let's get started. So the problem states, given a linked list, determine if it has a cycle in it. So here we have a linked list, 3, 2, 0, and 4, and we see that 4's next value is pointing to 2. So there is a cycle in this linked list, so we want to output true. And here is another cycled linked list where we have 1, 2, and then 2 points back to 1, so this is a cycle. And here we just have one node which doesn't point anywhere, so there is no cycle. So that way we would return false. So the algorithm for linked list cycle is actually pretty simple. What we're going to want to do is have two pointers, pointer 1 and pointer 2. So we can consider pointer 1 to be the slow pointer and pointer 2 to be the fast pointer. So to detect a cycle, all we have to do is increment pointer 2, which is the fast one. So the algorithm for linked list cycle is actually pretty simple. All we're going to have to do is have two pointers, one that is slow moving and one that is fast moving. And what we're going to do is move the fast pointer 2 forward, so 1, 2, and we're going to move the slow pointer 1 forward in every iteration of the loop. So all we have to do is check if the fast pointer has reached the end of the list or if the fast pointer is equal to the slow pointer. So the only time they'll be equal is in the first run when we initialize them, and if they're ever equal again, then we know that we have a cycle. So this is actually a very simple solution, but it does catch a lot of people off guard because they're not expecting to have two pointers rotating the linked list at different speeds. So now let's jump into the time complexity and space complexity. We know that we're only going to keep two pointers and iterate them in a while loop until they reach the end of the list or they cycle back to each other. So that's just going to be a constant space algorithm. And in terms of time complexity, even though the cycle can encapsulate the entire list and the two pointers can possibly miss each other the first run, we're not going to end up with a time complexity that is of n squared, or maybe the thing will loop 2, 3, or even 4 times, but it won't be relative to the number of nodes in the list. So we can quickly say that the time complexity is also going to be O of n. So the coding section is pretty easy once you understand the trick. First we want to check if head is none. If it is, we're just going to return false. Otherwise, we're going to set the current pointer to the value of the head and the fast pointer, the fast moving pointer, to the value head's next node. And all we're going to do is pretty much iterate through in a while loop, and I'll talk about these conditions a little bit later. And all we're going to see is if PTR is equal to the faster moving pointer. And if it's not, then we are going to continue with PTR by saying PTR equals PTR.next and continue with moving the fast pointer to the next.next. So here is the condition. This is a very important condition. You don't want to get this wrong, otherwise you'll go into a bunch of null case errors. So first we want to make sure that while we're entering the while loop that the PTR is not none, because if it's none, then this will fail. Then we want to make sure that fast PTR exists, because if that is none, then this will fail. And if the fast PTR's next value is none, then again, this will fail. So we have this while loop condition, and basically what we're going to do is we're going to iterate through in this while loop And if we ever come to a condition when PTR is none, or fast PTR is none, or fast PTR.next is none, then we just exit out of the while loop. And we know that that means that we reach the end of the list, so we can return false, because there are no cycles. If there is a cycle, we would have caught it inside of this if statement. Cool. Let's just submit this question real quick. And of course, I don't know why it is always so slow, whatever. Hope you guys enjoyed. If you did, leave a like and subscribe for more in the future. I'll catch you guys next time.